Hello everyone. So in this video we discuss about problems in eigens values and eigens vectors. Table of content. So introduction to eigenvalues and eigenvectors. Examples: two-dimensional matrix. Next one is three-dimensional matrix. And last one is types of matrix. Introduction. So eigenvector. In linear algebra, an eigenvector or characteristics vector of a square matrix is a vector that does not change its direction under the associated linear transformation. In other words, if V is a vector that is not zero, that is an eigenvector of a square matrix A, if AV is scalar multiple of B, this condition should be written as the equation AV equal to lambda V. So next, introduction to eigenvalue. So in the above equations, lambda is a scalar known as the eigenvalue or characteristics value associated with the eigenvector V. We can find the eigenvalues by determining the roots of the characteristics equation determinant of a minus lambda I equal 0. Using this equation, we can determine the eigenvalues. So A is a square matrix. What is meant by square matrix? A matrix is a 2B square matrix. The number of rows equal to number of columns. That means rows and columns are equal. Next example of two-dimensional matrix. Find the eigenvalues and eigenvector of a matrix A. If A equal to the matrix 2, 1 and 1, 2. You can find the eigenvalues of this matrices. So use the formula determinant of A minus lambda I equal to 0. Using this formula, we can simplify the given matrix. Determinant of 2 minus lambda 1, 1 minus 2 minus lambda is equal to 0. We simplify this one, we get the equation 3 minus 4 lambda plus lambda squared equals 0. So it has root at lambda equal to 1 and lambda equal to 3. These are the two eigenvalues of A. So eigenvectors V of this transformation satisfies the equations AV equal to lambda V. Rearrange this equation to obtain determinant of A minus lambda I into V equal to 0. For lambda equal to 1, the equation becomes A minus I into V equal to 0. That means 1, 1, 1, 1, V1, V2 equal to 0, 0, 0. Therefore, the solution is V equal to 1, minus 1. For lambda equal to 3, the equation becomes A minus 3I into U equal to 0. Simplify this one, we get U equal to 1 and 1, 1. That means the eigenvalues are 1 and 3. The eigenvectors are lambda equal to 1, 1, minus 1, and eigenvectors for lambda equal to 3, 1, 1. Thus, the vectors V and U are eigenvectors of A associated with the eigenvalues lambda equal to 1 and lambda equal to 3 respectively. So example 2. Find the eigenvalues and eigenvector of the matrices A equal to minus 4, 1, 0, 0, minus 3, 1, 0, 0, minus 2. The matrices has the characteristic equation lambda minus AI minus A, so lambda I minus A equal 0. Solve this given matrix, we get the equation lambda plus 4, lambda plus 3, lambda plus 2 equals 0. Therefore, the eigenvalues are lambda eigenvalues are minus 2, minus 3 and minus 4. Next, we can find the eigenvectors for corresponding eigenvalues. Lambda equal to minus 2, the eigenvalues is this eigenvalue. The corresponding eigenvectors are 1, 2, 2. So next, lambda equal to minus 3 and lambda equal to minus 4. The corresponding eigenvectors are 1, 1 comma 0 and 2 comma 0 comma 0. Thank you.